Okay, this is third time I'm doing this. Iowa caucuses are still going on. I think the video camera stopped working. Let's do this. We're going to discuss, from where we left off, type 2 and type 3 problems, because I think that's when the stuff got weird with the camera. Now, there's a fly on my screen. You can't see it, but I can. That's annoying. Okay. Angles. So, if you did your little web quest, you know 90-degree angles stay in the air the longest, but 45-degree angles take the distance farthest, and complementary angles reach the same distance. So, here I got this straight from the website, I just made it. This light blue line, this is the ball staying in the air the longest. This is the same projectile going the farthest, 45-degree angle. And this is two complementary angles. You can see they end up with the same range, just a little bit over 20. So now with type 2, we're dealing with the peak. There are certain properties of a type 2, okay? The peak is halfway of the range in these problems. So this is to say that of total delta x, the peak is half of that. The peak has a velocity of 0, and we can see that the peak is a velocity tangent to the curve, which in this case is horizontal. Velocity is tangent to the curve. Okay, said that. And then total time divided by 2 is the peak. Yes, so this is saying the time taking for the ball to get here to here. Half of that is the time that it takes for the ball to get from here to here. Okay, good. Now let us see if Bernie Sanders won. I don't know yet. It's still going on. That's crazy. So, we're given that velocity in this problem is 300 meters per second, so we break that into components like we always done. You can see that here. And then we make an XY chart. A equals 0, as always. A equals negative 9.8 for Y, because gravity is the only thing acting on it, as always. V0 and V are going to be the same, because the acceleration is 0. And in this case, V0 and V are 300 cosine 35. V0 is 300 sine 35, and V equals 0 for the peak. So this is the idea that we are actually going to be solving problems only to the peak. So in final calculations we have to adjust for that. And let me show you what I mean. Our questions are as followed. How long will it rise? How far up is the peak? Total time in the air? And then what's our range? Cool. So here we go with some basic plug and chug. We get V equals V0 plus AT, and right away we use the Y information so that we can get T, because that allows us to work with some of the information that we're missing in X. This is always something good to start with in general for really any projectiles problem. Work with the Y stuff as much as you can, and then work with your X stuff as much as you can. So with how long it will rise, we're saying how long will it take for the ball to go from here to the peak. So we get V equals V0 plus AT. Substitution gives us that T equals 15.3 seconds. And the reason I'm doubling this total time here is to solve the second question right here, total time in the air. So, well, 15.3 seconds is just how much is the ball rising, spending time to rise up to the peak. Total time in the air from here to here is going to be double that, so 30.6 seconds. I skipped. No, I didn't. Oh yeah, one thing I wanted to mention though was that V equals 0. Oh, we already said that. Okay. So now we're getting into delta x. Now that we know t, we can do delta x equals V0 t. We've done this before. 30.6 times 300 cosine 35 equals 7,522.8. Obviously, Charlie Brown can't kick the football at all. So these numbers are probably not reasonable. That's okay. We move on. Can I do something? I need to do something. Where's the Caucasus? Let's see. Yep. Nothing has happened. That's okay. Okay, back to this. How far up is the peak? So we're looking for delta y, and we just do delta y v naught t plus half a t squared. Plug and chug, 390 sine 30, 19.9 minus 4.9, 19.9 squared. Delta y is going to be 1940.05. Simple, easy to do. And then we get to type 3 problems. Yes, we do get to type 3 problems. Now, type 3 problem, webcam. I think you're working now. That's awesome. With the type 3 problem, we're dealing with the idea that there's going to be an actual change in y from where Charlie Brown is kicking the ball to where the ball actually lands. So it's going to land somewhere down here that we are not sure about. Let's move our little diagram up and see where the ball actually lands. Psh, mind blown. The ball is actually going to land right in the Iowa Caucasus. Amazing. I think it's amazing. Yeah. So, let's solve horizontal distance to get into the Iowa Caucasus. Oh yeah. Given that delta y equals negative 30. Perhaps I should have written that out. That's okay, we move on. So, given that delta y equals negative 30, you saw nothing. Okay, given that delta y equals negative 30, we can use delta y equals v naught t plus 0.5 negative 9.8 t squared. The second kinematic equation, simple plug and chug, will give us t. T equals 51.345 seconds. And then from there, we just say that, okay, now let's use our x-axis formula, which is always delta x equals v naught t, and we can find delta x. So really, even though we have type 1, type 2, type 3 problem, I think something important to note is that the procedure is really the same. And yeah, hopefully I will know what the result of the Iowa Caucasus is before this is uploaded on YouTube, where you can all watch me again, re-explain this in my terribly whispery voice, because everyone in my house is asleep right now. Good night.